Shall I start? Okay. So, hi everyone. So, last week we have discussed Hadoop ecosystem and its related tool. So, we have discussed how uh, MapReduce handles big data, how parallel processing works, what is HDFS, and what is a distributed storage. Along with that, we also see the various limitations in Hive. And in order to overcome those limitations, uh, Hadoop provided all the ecosystem tools like Scoop, Hive, and Pig, and other tools. So far we have covered Scoop, that is a data ingestion tool that extract data from RDBMS sources and do an ingestion into data lake, HDFS. Now, after that, we have discussed Hive. So Hive is a analytical tool on top of HDFS, and we can do transformations, doing analysis on the HDFS data using a SQL engine. So, so as we discussed earlier, that Hive is a SQL engine on top of HDFS, and we open. This is what we discussed last week. Uh, that Hive contains a driver, and also we can interact with Hive using CLI and a web interface. And we can fire HQL queries on a Hive driver that will be auto converted into MapReduce and interacts with your HDFS, and it stores its metadata information in RDBMS source. But um, we can apply Hive optimization techniques before loading our data into Hive. So the optimization techniques that we have discussed was partitioning and bucketing. We also have discussed Hive joins. In Hive joins, map join, we have covered bucket map join, SMT join. We have also discussed file formats. Today I will discuss what is file format. In file formats, we will discuss Avro, Parquet. These all are the file formats available. ORC. Okay. So now In Hive, we also have window functions. There is a transformation functions available. So let me discuss window functions. So in window functions, we can categorize window function in three categories. So we have aggregate function. We also have analytical function. And we also have ranking functions. Then ranking function, we have rank, tens rank. In analytical function, we have the cumulative distribution, the stack functions. In aggregate function, we have min, max, mean. These kind of functions are the aggregate function. So let's see one example. So first connect with the Hive server. So Cloudera provided all these environments. So first get the IP address, connect via portal. Start Hive shell. Now start MySQL shell. Mhm. That's something wrong. This is a Hive metastore. You can check the meta table. These all are meta tables. And now also start one more session, HDFS. Now, Let's create this data. This is a table. Okay, this table is created. Might describe the schema of this table. So we can see that there are three columns in this table. So first column is the ID column, employee ID, the employee name and department name, salary and age. Like these are the five columns. And now load some data into this table. Now it's loading this data. This is the MapReduce run job run that is loading this data in this table. Where it is stuck. I need to restart this Cloud AI environment. Let me close this. And restart. In the meantime, it's starting, so we can recall a few things. So as we can see in this architecture, what we are trying to do, we are submitting a job through CLI on the driver, and this is for the table that we have seen that we are trying to create this table, and then we will apply these window functions on this data sets. So first function is the rank function. The rank function is We'll apply this just to find out who earned the most and which employee has highest salary in each and every department. For that, we will run these queries and we will understand what all operations it perform. So we have other functions like lead function, lag function, first value, count, sum. So all these are the window function that are related to these categories. So that we are going to apply. And once this window function is finished, then we will create our own functions, the UDF functions. Okay, so that is the agenda for today. Let's wait for a couple more minutes. Let's be starting. So in the meantime, it's running. So I can give you overview uh, after Hive. We'll start Spark. Okay, and Spark is again a part of Hadoop ecosystem or big data ecosystem. So Spark is alternate for MapReduce, and it processes data in memory and it's fast in comparison to MapReduce. And also we have multiple APIs available in Spark, and it provide APIs in languages like Python, Scala, Java, and R. So we can write Spark job in any of the languages. Okay. So um, as we can see here, uh, Spark is it has a core engine. Okay. And also these are the different modules available in Spark. So streaming module, machine learning module. So we can develop big data analytics application using Spark ML. We have Spark graphics to develop graph applications. So if we go to the official documentation of Spark, so we can see various modules. So you can see this is Spark code properties. This is for real-time application, Spark structure streaming. Then we have machine learning, Spark ML, and graph application. So graphics to develop graph applications. So, so first, we need to set up Spark on our local in order to run our Spark job. Cloudera also provided Spark environment. So uh, first we need to set up Java and Python. So we just need to download Spark from here, and here Spark 2.1, this version, the highlighted one, this one. So download the Spark version and place it in some directory. So I have placed it here, and then we need to set the path. So here we can see I have set the Java path and also the Spark path where I have placed Spark. So after setting up the path, then we need to test whether Spark is running or not. So just write PySpark. So it will start Spark shell in Python. So now it's starting the PySpark shell. Okay, PySpark shell is started. So in a similar manner, we can start Scala Spark. It will start Scala Spark shell. So this is how we set up Spark environment. Okay. So here we can write as the Scala Spark code, and here we can write a PySpark code. Okay. So let me check. Um, First we'll finish Hive, then only we'll switch over to Spark. So I have explained how we set up Spark. In the prerequisite is you need Java and Python, and then you can start this Spark environment. Cloud is still starting. Okay. Now Cloud is started. Now we can connect. Remove Hadoop user interface. Hit the IP. Connect with okay. Now we use Cloud. Start Hive shell. So it's starting the Hive shell. Okay, Hive shell is started. Now we can check the table. So we have T employee table. Now insert data into this table. So MapReduce job is running. So this job will import the data into this table. So you can see these map and reduce maple and reduce threads are running. It's trying to load data into this table. The job is still running. Okay. In the meantime, it's running. So we have started these Spark environment where we can run our Spark job. So we can also uh, set up Spark on cloud as well. So this Databricks community.databricks.com. So this account is available in free tier. So we can create our account here on Databricks. So Databricks also provide the cloud environment or Spark environment. Here, this is our workspace and this is our notebooks. So here also we can practice our Spark jobs. So this database also provide the Spark environment. Still good. So data load is finished. Now we can verify the data using the select statement. And this is the data. So uh, your data is persisted in HDFS. This is just a virtual tool. So let's verify whether data is persisted in HDFS or not. So go to Hadoop warehouse. So Hadoop file system, FNLS, and warehouse is user Hive warehouse. This is the warehouse directory where all the Hive internal tables stored. So Hadoop file system, FNLS. Now it will provide the result of this warehouse directory. So a table is created with the table name, and inside this we can check our data. So this mapper contains the data. So let's open this and verify. Okay. So we can check this data is loaded in HDFS. Okay. And also now we can verify the metadata information. Metadata is kept inside MySQL. All these are metadata. So the data is kept inside this PBLS. Now here we can send this entry for the employee table, and by default this table is a managed table, or you can say implement table. Now start implementing window functions. So for window functions, now we need to find out the max salary in each and every department. Okay. So first execute the inner query. Okay. So here we can see there's a over function. So over is a window function. So basic signature is that we have aggregate, analytical, or rank function over, and within over function we have three arguments. First is the partition by, then order by, and third is row range. Okay, so partition by, just like a group by, and then we do ordering in each and every window and the row range. So in this case, we have creating partition based on department name. So here we have the department column. Okay, and then we are doing the sorting based on the salary. So, and now in each and every window, it's calculating the rank. So the employee having highest salary assigned rank as one, and then second highest, third highest. So let's execute this query and see the results. So this over function is a window function. Okay, so we can see this department management. So Matthews having highest salary because it assigned rank as 1, 2, 3 in production department and then in sales department. So we can run the external query as well. So let me execute the whole query. So this query will filter out the results where salary is highest. So rank 1 is having the highest salary. Okay. Okay. So as we can see in management department, Matthew having higher salary. Then in sales department, Sophia having higher salary. And then in service department, Elvis. So using window function, we can uh, calculate the highest salary in each and every department. Now next case is cumulative distribution. So here we can calculate all the cumulative distribution of salaries among all departments. Okay. So cumulative distribution means it will find out the percentage. So let me execute this. So all we need to do is just to change um, the sum of. Let me execute this. So here cumulative distribution over this window. Okay. And then here this percent rank, again percent rank function is a predefined function. So we are applying this function on this. So here we define two windows, one for cumulative distribution and one for percent rank. Okay, so we can see the cumulative distribution and also the percent rank for the salary column. Now this query will find out the count. This one. Okay, let's see this one. So there are a lot of window functions available. So lead function is another function. So lead function provide access to a row. Okay, is the in the forward direction. So it will follow the current row and provide the results in the very next row. So let me execute this. First, prepare this data set. Yes. Okay, first, we need to create a table. Transaction table. This data is, oh no other able to do this. This column, this data is not a column name. Transaction date. There's something wrong with the third column. Okay, 1 minute. So here also we can apply the lead value. Okay, lead function. So with this, our table name is T employee. Now lead on which column? So let's say we apply lead on salary column. Partition by department. Partition by department name. And order by salary. Okay, so let's execute this query. Into the window invocation to at least one group must be dependent on input column. Department name column is this is depth name. Now check. Now it's working. So we apply lead function on the salary column. So it will provide us the lead. Lead means the next value from the current row. Mm. Okay. So this is the lead value. Okay. So for the management department, the lead value for 4,000 is this, for 4,400 is this, and now here there is no lead value, so it's going as none. Same thing apply in the production department, then the sales department. Okay. So now we can apply lag function in the similar manner. So it provides the value in the previous row. Okay. So let's apply this. Means the partition name. Revenue followed by Sunday. There's something wrong. Invalid table amount. Here, land salary. Not so. So this is the previous value. So previous to this is nothing, the null. The previous value for this row is 4,000. So it's giving 4,000. So this is the lag value in this column corresponding to each and every row. Okay. So now we can check the first value, last value. Okay. The count to total count uh, using this count function. Then we can use min and max function. So maximum value. Then average function, rank function we already discussed. We also have dense rank. So there's a problem in rank function. So if we see the table results, So here, uh, if two employee having the same salary, then it will provide the same rank. So let me insert one more row in this. So insert the same salary. Now we already have 11 columns, so make it 12, and then here by choice and salary 4,500. Okay, this can be anything. Add one more row. The same salary in same department. So let's insert this. Um, Make it as 13. Now these two rows are inserted. Okay, so these two rows are inserted. Now in place of first apply rank column to find out the highest salary in each and every department. So this is the query. So let's apply this query and let's check the maximum salary. So here we can see uh, Metro and Charles having the same salary. But if we see the rank, execute this inner query and see how it assigned the rank. So we can see that in this management department, so Matthew, Charles, and Olivia, Matthew, Charles, and they're having the same salary, so it assigned rank as one. Then after that, it skipped. So this is second highest salary. So it skipped 2, 3 sequence. It skipped the sequence. So now it's showing 4 for the second highest salary. So this is the problem with rank function. So here we can apply dense rank. So dense rank doesn't break the sequence. So just write dense rank and execute. So here we can see it doesn't break the sequence. So these three employee having the highest salary and then the second highest salary. So it assigned for second highest salary as rank 2 and rank 3. Now lead, lag, first value, count, sum, average, rank, dense rank, row number, percent rank. Okay. So now this is a special function in time. So these functions you guys can apply. So in every function, we just need to uh, change this function. If we see here, so here we need to change our function. Just window is still the same. This is how we define window, and outside of this window here, we can apply average, uh, lead, lag, percent rank. So we can change function accordingly based on our use. So next is the entile function. So entile, what is entile? So it divides the rows in each window to the buckets. So we can define the buckets. So we discuss bucketing, partition and bucketing. So here let's do the same thing. And so using hashing algorithm, it just store the data in the buckets. So within partition, we have buckets also. Same concept applied here. So let me apply this. Let's change the column names. Partition by department, order by link, from table, the employee. Invalid table. Yes, yeah, this one, alias. Now it executes. So we can see it create bucket pairs within partitions. Now next is, so this is just the flavor of window functions. So why we use window function and how we apply window functions. Okay, so you guys can practice. We have these three categories. Now the next is the function that are not available in Hive. So let's say there's a median function. This is not available. So we can create our own user-defined function. We can create the functions based on our use case, the functions that are not available in Hive. So let's see how we create a user-defined function or UDF in Hive. So let's open Eclipse because Hive is based on MapReduce. So we need to write Java code to create our own function. So create a Java project, Hive UDF, user-defined function. Let me see code. So let's create one function. Create a Java class, split. Now I will explain this code. Now these libraries are missing. So add these libraries. So go to project path. In the project path, add external jars or Java build path. Add external jar. Go to user library. Hive. Add these Hive libraries. So these libraries are added in the project. Now this is Hadoop library, Hadoop import. So add Hadoop library as well. Again, go to project path and add external jar. Use the lib. This is Hadoop. So add this Hadoop library. So here we can see now this it will get this class after adding this library. So now what this code is doing, here we can see our class is extended the UTF class. So this is a pre-built class available in Hive. And this class is used to generate the user-defined function. So from this class, this valued function overrides. Okay. So this valued function overrides from here. Um, so in this function, we can see if we send one string, and here we are sending the characters that we need to strip, or we can say we need to remove from the string. So it will check if string is null, it will return null. If it's not null, then it using the string utility, it will try to, it will strip those characters from our string. Okay, so let's export this. Export this Java jar. Export this as, let's say, strip jar. Desktop. This is the jar. Now, if we create uh, any external code, so we need to register this jar in Hive. So how we register a jar? So let's go to Hive. Ls, and go to desktop. And on desktop, we have this jar. Okay, so go to Hive shell, add jar, the path of jar. Load it up, desktop, this jar file. So this jar file is added. Now, once this file, the jar is added, now we can use this jar. Okay, so but before using this jar, we need to provide uh, a function name. So provide this class as a function name. Okay, so I shall Here also it's Hive shell is started. Now here we can give our function name, uh, name of the function as the temporary function name. It's like this. Create temporary function. Create temporary function. Right now it's hanging on my. So I think you guys uh, got the points how we create a UDF function, user defined function. So we just need to create a Java code, okay? And inside Java code, just write your own logic. And after writing the logic, register uh, that jar in your Hive shell as using add jar command, and then start using that function in your SQL queries. So this is how we define a user-defined function. Now that's it in Hive. Now we can start this file formats. It's common in both Hive and Spark. So I will cover this point tomorrow. Let's get started with the Spark now. So far we have covered MR, we have covered Spoke, we have covered Hive, we have covered now the Spark. So Spark, as I said, it's again it's a ETL tool on top of you can say it's an alternate for MapReduce. Okay. So Spark has multiple modules. So one is the core module, that is core Spark. Just hold for a minute, just 1 minute. Okay, so it has a module called Spark Core. Okay, so Spark Core module contains Spark session and other core Spark properties, or you can say libraries. Now, next is Spark data frames. Spark data frames, or we can say, and we can run Spark SQL on top of data frames. And we can develop a batch application. Batch application means the application that is scheduled on certain intervals. Next is for real-time application. We have Spark streaming. Spark Streaming that is based on uh, RDDs. I will explain what is RDD, and we are calling Spark Streaming as D streams as well. Next is Spark Structure Streaming. Spark Structure Streaming. So it's based on data frames, and yeah, it's based on data frame APIs. Now, next type of application that we can develop using Spark is graph application. So in graph application, we use Spark graphics. That is based on RDDs, and Spark graph frames that is based on data frames. Third, fourth type of application that we can develop is analytical application. So here we use Spark MLib that is based on RDDs, and Spark ML that is based on data frame. Okay. So Spark is available in 4 languages. So we can write Spark code using Python that we are calling it as PySpark. Then using Scala Spark. Then using Java, that is Java Spark. And then R, that is Spark R. So in these 4 languages, we can write the Spark code or Spark jobs. Okay. Now we can see those APIs here. So here, this is the official documentation. The API, we can see the Scala API. So all these are Scala Spark classes. So these are the packages available. Okay. This is Scala Spark packages. So we can see this is graphics, core packages, or ML packages. Okay. Now, next API is this Python. This is PySpark. So all these PySpark classes and APIs are available that we need to use while we are writing a Spark code. Next set of APIs is for Java. So these all are predefined Java classes that we need to use while we are writing our code. These are the Java packages. And the last one is Spark R. These are Spark R libraries for writing our Spark R jobs. So now our environment is here. So this is PySpark. Now here we can write our Spark code. So let me uh, show you one code. Now, to see this example. So here we are reading a customer file. Okay, there is a customer.csv. This is the file. And now let's assume this data is a huge data set. This is big data. And now we need to analyze this data, or we need to process this data from source to target location. So we use PySpark in that case. So, so if we are writing a Spark job, so first is the data extraction step. So here we'll create our data frames first. So let me execute this. So here when we start the Spark session, so when we start the Spark session, so there is a Spark session object available, and Spark session object is Spark only. Okay. So use this object to create your data frames. Okay. So let me write the code. So create this config object. First import all these libraries. So these libraries are imported. So here this Spark context, SQL context, row class, and then now create Spark context, the core context, and then the SQL context is a SQL context, and now create a RDD. So Spark context provide a function called text file where we can pass our data path. So it returns a RDD. So now lines dot for each. So in order to print the data of a RDD object, we use this println. Println is not defined. Oh, sorry. Lines dot. Oh, yeah. Lines dot for each one. Now apply a map function. So it will do a split. Okay. Now after doing the split, again we are applying a map function, and here we are mapping our columns to these column names. So first column as ID, second column as name, and city, third column as city. Now this is customer identity. Now SQL context provide create data frame function. So in create data frame, we can pass this RTD. It will return a customer data frame. Now schema customer dot show. It will show the result of this data frame. We can create data frame directly as well using this Spark session object. So Spark dot um, read dot CSV function, and here path the provide the path of your data set. So your data path is this only. It returns a data frame that we can write show to check the result. Okay. And now um, Uh, we can add one more parameter to capture the schema. Dot read uh, dot option file. Options, and the options pass infer schema as true. Dot load, in load function we can path, provide the path. There's something wrong in first schema. 1 minute. To check infer schema. Infer schema. Infer schema. So now spark dot read dot option. Yes. So based on our data, we can define our schema as well. Okay. So use this code to load the data. So what we can do here, our data is this. So first is the customer ID column. So add customer ID here. This customer ID is of integer type. Then name and city. Name is of string type, and then city. City is also of string type. So write string type here. Pass this custom schema here, and then it's reading header as well. Okay, or we can say skip header true. So and then path of the CSV file. So CSV file path is this. Now create the data frame, but I don't think it's applicable to Python. Let's see. Hmm, there's something wrong here. Option header true. This is, let me check one more. This is the right. This one is fine. You can use this. So spark.read.option header true. Infer schema. Infer schema means it will capture the internal schema of our data. Our data is, we can remove the delimiter, that's not required. And then the path of our data frame. Where we are executing the Spark code there. So your data frame is created. Now data frame dot show. So here now we can see the results of this data frame. So spark dot read dot option header true. Infer schema means whatever schema, the internal schema. Internal schema means the whatever schema data have, just capture that schema. and then the path of the CSV file. Now we can select the columns. Let's say we are selecting name dot show. So it will show the result after selecting this column. So we can execute uh, Spark SQL as well. So Spark dot register temp table. Now we can give any temporary table name. Let's say customer only. Dot show. No, not show. First register. Uh, does not have attribute register temp. Also register temp view. Why it's throwing error? Register temp. 1 minute. I'm doing wrong. So df dot register, not spark dot register. So df dot register temp table customer, and then we can run our SQL queries. Like select start from customer dot show. So we can run a plain SQL queries. So we see on data frame we can run Spark SQL as well. So this is how we analyze data in Spark. Okay. So in Spark, what we need to study, we have these three set of APIs. So first is RDD APIs, data frame APIs, and data set APIs. So data frame APIs, or you can say data frames, are faster than RDDs because data frames are auto optimized, and also the functions that we use for data frames is similar to SQL only. Okay. So now I've shown how we create a data frame. So on the, it's like this data frame is just like pandas data frame of Python. In Python, we have pandas library. So using pandas also we can create a data frame. In Spark also we create data frames. The Spark data frames are distributed, means it runs on the cluster. So Spark also have a cluster just like HDFS. So in Spark we have driver and we have worker nodes. So we can create any node cluster based on our data. Okay. So this is Spark driver, just like uh, HDFS. In HDFS we have name node, so we have Spark driver node, and we are calling slave nodes as worker nodes. Worker node. Now on the worker nodes, executors are available. Is there any size limit for data frame? So as I said, um, this Spark data frames are lazy initialized. So lazy initialized means that your data is not loaded until we perform some action. And when we perform some action, it creates a partitions within data frame. So data frame contains partitions, just like MapReduce. And MapReduce also it create partitions, and that partitions process on this cluster. So Spark detects the partitions, okay. And on the worker nodes, we have executors available. Executors. An executor, if you guys are aware of thread pool, so executor manages thread pool. This is thread pool two, and inside thread pool we have threads. Then there's an interface available. That interface manages threads in a thread pool. Okay, so these threads are continuously running within a thread pool until it processes the whole data. Okay, so these thread pool are managed by executors. Executors. So we have executors on every node. These executors manages the thread pool. So we'll go in detail uh, in the next class. But as I said, we have a Spark data frame concept, and here we submit our jobs on the Spark cluster. So here in interactive shell, I show you how to run a Spark job in interactive shell. We can run the job from cluster itself. So let me show you how to run a job from cluster. So go to bin. So let's create one Spark job. So just understand this job. This is the data. Okay. It contains first name, middle name, last name, DOB, gender. First, we are creating data frame. Then we are printing the schema and then check the result. Then we are adding the a new column, the salary column. So this we'll discuss from the next class. But see, this is a Spark script. Okay. And in this script, I want to submit the script on the Spark cluster. So just using Spark submit tool, using Spark submit, we can run our job. So our job name is Spark test. And now this job is submitted on the cluster. Okay, this job is running. Now we can track this job localhost 4000. You can see this job. So we'll discuss this. This is Spark UI. So on the Spark UI, we can check the various detail what environment it uses. Okay, and the number of stages that it created. So here we can see this job is running. Okay, so this is how we submit a Spark job on the Spark list. And this is the UI for that particular job, and the job that is running in the background. Okay, so job scheduling is before any other model is used in Spark. Okay, so in Spark, Spark has its own cluster manager. Spark also comes along with the cluster, Hadoop cluster manager. So here we have Yarn. So Spark has its own manager, Spark manager. Now we can use Spark as well to manage the Spark cluster. We also have Mesos and we also have Kubernetes. also to manage the scope cluster. Okay, and mainly yarn is used. And if you talk about scheduling, so yarn having two schedulers. One is capacity scheduler and fair scheduler. Okay, another one is fair. So when this FIFO scheduler, this is not a good option in case of distributed environment, because if you use FIFO, so whenever we submit multiple jobs on the Spark clusters, so your job will wait in queue. So that is not a good option. And whenever we submit it, that job needs to execute at the same time. So this is done by capacity and the fair scheduler. They uh, capacity scheduler provide the resources based on the you can say if there is a high execution job that is processing more data, then it provide more capacity to that job. And in case of fair scheduler, it distribute equal resources to all the jobs that is submitted on the cluster. Okay. So can we provide can we provide custom scheduling? Yes, in every cluster we can provide custom scheduling, but this scheduler is different from the job scheduling. This is the cluster, how cluster is managing the resources when multiple jobs are submitted. That is within cluster only, within product only. And that the scheduler that you are talking about, that is for scheduling our jobs, the jobs that we create, the timely, the batch scheduling. That is different. That is done through Oozie only. So that is also a tool that we need to cover. So this one, Airflow or uh, Airflow or Oozie, these are custom schedulers. Okay, that I will cover in the upcoming sessions. But these are two different things. The the scheduler that is managing cluster resources, that is inbuilt to the product. And the scheduler that we use for executing our custom jobs. Okay. So here, um, as I said, in Spark, first we read our data. So that is our data extraction step. Okay. So this is how we read data. So SC is Spark context. So either we create data frame directly, or we can create RDD, and we can convert RDD into data frame. But converting RDD into a data frame is not a good option because it will have the performance impact. So better is to create data frame only, or just write your entire script or code in RDD only. So here in this example, we can see that here we are creating data frame. So uh, we are providing the path, it returns a RDD, and then we are applying a map function. So doing a split based on the comma, it returns employee token RDD. So there are two types of functions available in Spark. One is narrow transformation, another one is wide transformation. So there's narrow and wide. So narrow transformation means these flat map, filter, sample, union, all these are narrow transformation. Narrow transformation means, so let's say in the first line, this employee data frame is created. So it contains some partitions. Then we apply a map function on this RDD. It returns another RDD. That partition will hold the similar partitions in case of narrow transformation. Then we apply another narrow transformation. It returns another RDD that also contains the same partitions. So that is because of narrow transformations. But when we apply wide transformation, so wide transformation means the grouping, joining and repartition, coalesce, reduce. All these are data shuffling function, data shuffle. Because of these functions, data shuffle happens. So you can see uh, your partition changed because of the data shuffle. These are intermediate partitions. So all these Y transformation functions causes data shuffle, and we always try to reduce the data shuffle as much as we can, just to enhance the job performance. Okay, so this is your this example, this group by, it returns RDD again, but it's a RDD that is created after data shuffle. So we'll continue on this tomorrow, these RDDs and data frame concept. And this we can see whenever there is a data shuffle, your stage switch. So when we run a Spark job, so there we will have the task, stages, okay, partitions, so executors, uh, the memory that we allocate to the executors. So we, you can say, monitor our job. So if any job is running slow, so we monitor these things in our job to optimize the job performance. Okay. So how we calculate that number of stages in a job? We calculate using these transformation functions. So as we can see here, here data shuffle happens because of byte transformation. So stage switch. Until and unless another function came, so this stage will continue. And once we have the byte transformation, then it's the stage switch again. So that is the relationship between stages, task, job. So that relationship is here. Uh, this one, task executor um, nodes. So one job contains one more stages. One stage contains more tasks. So we'll see tomorrow the job stage relation, stage task relation, task executor relation. So that we'll see when we see the DAG UI. So in the DAG graph we uh, see this the relationship between the components, Spark components. Okay, so that's it for today. Um, the code in slide is Java code. The one you ran is Python. No, this is not Java. This is Scala only. And if you remove this val, remove the val only, it you can say it's Python only. Nothing has changed. So you need to understand Spark concept. It doesn't matter you are writing in any language. Yes, I will prefer. I will uh, show you the Python script only, but these are Spark concept, not language specific. It's just the syntax change. Okay. So just if you remove val only, so it's you can run in PySpark also. Some functions are changed. I'm not saying that it's just the val removal, but more or less is same. It's just the syntax different. Otherwise, you need to understand RTD, data frame. These concept or these functions are provided by Spark only. So that you need to understand. Any other question? Okay. Okay, guys. So that's it for today. We will continue tomorrow from the same, um, you can say, tool, the Spark. And after covering Spark, I will pick one scheduler, whether it's Airflow or Oozie, and then all we will cover all the ecosystem tools. And mainly when we work on a project, so we use Scoop, Hive, Spark, and one NoSQL database, HBase. I will try to cover, and the scheduler also.
Yeah. Thank you, Naveen.
Okay, thanks, Chandana.
Yeah, guys, hope you enjoy the session. Is there any queries? Please let me know in the chat box regarding LMS and recordings, notes, and all. And I'm sharing the feedback link in the chat box. Please make sure your attendance.
I'm dropping off. Okay.
Yeah, yeah, you can
Okay.
carry.
Well,
I hope there is no more questions. So we'll wind up the session for today. Thanks for joining. We'll meet on tomorrow. Yeah, up to then.